And it's in improper integrals. Okay. So this first example here, I'm just going to call it number 1. It says, let R be the region between the graph of y equals e to the negative 2x and the x-axis for x is greater than or equal to 3. Okay, so what we're doing on this is we're taking 3 basically to infinity, because that's what this means right here. Okay, this thing right there means you're taking 3, that's the lowest that you can go, and then you're doing greater than or equal to 3. So you're taking 3 and then going to infinity as well. And you're looking for the area of R for this. Okay, so essentially what we're doing, if we're going to translate all these words basically to math, is we are going to take the integral from 3 to infinity, okay, of e to the negative 2x with respect to x. Okay, so that's always step 1, is actually get the problem, whatever it is, whatever the expression is, try to make that integral expression from the information that's given there. So the area of R is what? Okay, well, the area, we went over that before with definite integrals, from a to b is using the antiderivative. You plug in b, you plug in a. This one, the a to b is 3 to infinity. Now, if you wanted to, you can write a b up there and say b, the limit as b is going to infinity instead of writing that infinite symbol, but it doesn't matter. So from here, it's actually the same rules as before, okay? That fundamental theorem of calculus. You find the antiderivative, you plug in b, you plug in a, and you subtract. That's essentially what we're going to do here, all right? So the first thing that I'm going to do is find the antiderivative, okay? The antiderivative here, if you notice, it's a buried function. So if you wanted, you could use u substitution, or you can just kind of use the shortcut of do the antiderivative of the outside layer, which is just going to be e to the negative 2x. The antiderivative of e to the x is e to the x, so it's just itself. And then you just divide by the derivative of the inner layer. So you're just going to divide by that derivative right there, which happens to be negative 2. The derivative happens to be negative 2. Okay, and then that's embarrassing. Then we're integrating this from 3 to infinity. Okay, now if you wanted to, you could definitely use limits on this rather than putting infinity up there. I don't really care, so I'm just going to do it that way. But you'll see on my answer key, I usually use limits for that. Okay. For this, actually, let me just show you what I'm talking about, just in case someone's confused. So you can put a b here, and then this is still a 3. And then you can just write, I'm going to shrink it down here. You can write the limit as b goes to infinity. That's what I keep talking about when I'm saying you can use like a letter, like a variable, versus just the actual infinite symbol. Doesn't matter for me though. Okay, but I'm just going to do it for fun there. So we're going to have, this is going to be equal to the limit. You have to keep that there. As b goes to infinity. Now we're plugging b in to the antiderivative. So it's just going to be, I'm actually going to rewrite it. So it's going to be 1 divided by negative 2 e to the negative 2b. Oops, not negative 2, because I put it on the bottom. To the 2b. Okay, so it's negative 2x, so I just put it on the bottom. So it's 1 over e to the 2x, and then I plugged in b, because that's the first part you're supposed to do. So that's plugging in b. And then we're going to subtract this. Let me use a different color here. We're going to subtract this from when you plug in 3. So now it's going to be 1 over negative 2 e to the 6th. Okay, so I plugged in my b, I plugged in my a, and we subtracted them.
I have just a quick one.
Yep.
Is it just like formatting that you set it to the limit all the time, or how come it's set to the limit again?
Oh, because technically speaking, you can't put infinity, like you can't just put an infinity symbol in here, because infinity is not a number that you can do that with. I have seen teachers do it though. I've seen professors do it. I've seen students do it. I've seen books do it. So the limit is just so you can do a variable of b. Like the correct mathematical way of doing it, the math notation, the official, is you have to use limits. Because that way you have like the b there. But if you just put an infinity there, it's the same thing.
Oh, okay. So like technically, I know it's kind of incorrect, but it's technically like set to a number, but the number is the limit.
Right.
Okay.
Yeah, but I don't care if you didn't do the limit. I'm just doing that so I match the answer keys of what I've done, and just so people understand what I'm talking about. Because I keep talking about, oh, throw the infinity in there. But it would be no different if it said 1 over negative 2e to the 2 times infinity. It's just that, again, somebody someday decided, oh, you don't use infinity like that. Oh, okay. I don't think it changes anything if you do have the infinity like that, but I don't know. I'm sure there's some good reason out there.
Okay, sounds good. Thank you so much.
Oh, no problem. No problem. Thanks for asking. All right. So the yellow, I'm going to focus on that yellow part first. If you have 1 over negative 2e to the 2 times infinity, you essentially have 1 over negative infinity. Does anybody know what 1 over negative infinity comes out to be?
0.
Thank you. Whoever said that. Thank you. This is 0. Okay. If you have 1 pizza and you divide it by infinitely many people, essentially nobody gets any pizza, right? If you think about it, you have 1 pizza, you divide it by 1 person, that person gets 1 whole pizza. Now, if it's 2 people, each person gets a half. If it's 4 people, each person gets a quarter. If it's 1 billion people, each person gets 1/1,000,000th, which is, I don't even know if you can cut them that thin. Okay, but we're going past 1 billion. We're going to infinity. So it's basically everyone gets nothing. The limit is nothing. Really, it's not nothing. There's a little bit of something there, but the limit is nothing. That's why another reason probably why they use limits there. Okay, if you could get to infinity, it would be nothing, but you can't. So either way, the limit is nothing. Okay, and then plus 1 over 2e to the 6th power. Obviously, 0 plus that is just going to be the second part here, and that ends up being your answer. Okay, even though we went to infinity, it still actually comes out to a constant, which is, again, really weird to think about because technically it shouldn't just be infinite area. We're going to explain a lot more of that later on in the course. All right, so say we had a function that was, what was it, e to the negative 2x. Okay, it looks like that. Okay, and as you can see, if I mess with this, if I zoomed in here, it's not actually crossing the x-axis. Holy cow, do I have to zoom in there? It's not really hitting the x-axis. The x-axis is right there. You can see it's a little bit above 0. The y value is a little bit above 0, very tiny bit above 0. It never actually crosses 0, though. This can never be equal to 0. Okay? If you tried to solve it algebraically, you would run into a dead end. Okay, what we're going to do is we're going to, what's cool about Desmos is you can do the integral from 3 to, I'm just going to do 10, okay, of f of x with respect to x, and it spits out that value there. Okay, but the thing is, we're not, and just for reference, I'm going to do 1 over 2e to the 6th here, just so you kind of get the value. Oh man, that just shows it right away. That's embarrassing. Okay, let's just do 4. Okay, and then here's 5, 6. Now we're supposed to go to infinity. 8. Okay, so what I'm going to do is put a 10 in there, and you can see it's pretty close already. Hopefully you can see these numbers. These values are pretty close. We're not even at infinity yet. We went 3 to 10. But watch this. I'm going to do 100. Now it's going to be exactly that, if you notice. Now, it's not really exact. It's just this ran out of memory, so it stopped spitting out numbers. But if I just kept putting a bunch of these in here, I mean, eventually it runs out of memory. But you get the idea. Eventually it's going to be the exact same, and I didn't even go to infinity. Okay, so it's just kind of interesting. I don't know. I think it's super interesting because you're going to infinity and you're adding a little bit of stuff there. But the thing to think about here is that e, if you know anything about e, the value here, it's 1 over 2e to the 6th. E goes forever. Okay, it's like pi. Okay, it's an irrational number. Okay, the decimal values just keep going over and over and over again, which is kind of interesting about where that comes from. Because I don't know, I feel like a lot of teachers don't really show you that. They're like, hey, this is pi, it's pretty cool, but the numbers go forever. Well, why? Why does it go forever? It was like, why is that a rule? And it shows it here because you're going with the graph forever. You're adding up smaller and smaller values, so it's just tacking on more and more decimal values after it. You don't need to know that. I just think it's cool. But anyway, that's kind of what I kind of want to show you that graphically, just because I think that's cool. And also, if you wanted to, you can actually check this problem with your calculator. Okay. Let me try to do it with this fake calculator. I have to share my. So what you can do, and I would take your calculator out because this is kind of cool that you can do this. Hit math 9. Okay. And then we're going to go from 3, and we're just going to do 3 to, let's just do 100. Okay. And then you can put in the value. So it's going to be e to the negative 2x. Negative 2x. The dx is already there. Let's see if this works. Okay, and then you get that decimal value. And then what you can do is you can check your work and see if it's the same thing. So we're going to do 1 over 2 e to the 6th. And boom, it matches. So then at least you know you did it right. Okay, you can throw in your calculator and then compare it to the answer that you do have. Now, if you wrote that as the answer on a test or a quiz, the 0.0012393761, I would know that you probably didn't actually do the problem. You didn't do the antiderivative. You didn't show all the work because the calculator is not going to do that for you. But I mean, some calculators do, but it's just a good way of checking it. So there you go. Hopefully you can see that. I'm sorry. This is the best I can do for a TI emulator online. Let's do another problem. So we're doing the next problem that's on that slideshow that I sent. It looks like this right here. If you notice, it's just the expression right away. The one thing that is tricky on this is it doesn't look like an improper integral because there's no infinity. There's nothing, yelling at you and going, hey, look at this. It's an improper integral. You have to actually analyze the problem and see what it is and why. The main thing is this thing right here, this 1 minus x, you're going from 0 to 3. X equals 0 to x equals 3, which means you're passing 1. Okay? 1 is where a vertical asymptote is happening because you're dividing by 0 there, because it's 1 minus 1 is 0 on the bottom. Okay, so that means there's a vertical asymptote at 1. Just so you can kind of see that again visually, what I'm going to do is screenshot the graph of this in the whiteboard so you can kind of see it. So it's going to be 1 over 1 minus x squared. Let's do this. So I'm just going to screenshot this and throw it in the whiteboard. So it looks something like this. Okay, so we're definitely going to infinity because at 1, here, let me use my highlighter here. At 1 right here, you can see that's where the vertical asymptote is. Okay, so if you try to do this problem just by going through it and acting like that it's not an improper integral, you will get the wrong answer. I actually did it ahead of time, and you actually get like a negative 3/2 if you try to actually do the problem, unless I did it wrong. Either way, there are certain instances where you can get it wrong. If you just try to do this like any other problem, like any other integral, you would get the wrong answer. So what we have to do is, and this is going to involve a little bit of limits here, is we are going to, here, let me zoom in. We have to break down this integral, and if this is going to be equal to, we're going to do the limit as, let's just do b. B approaches 1 from the left, okay? And then we're going to do the integral of 0 to b here, okay? Of bx over 1 minus x quantity squared, okay? So that's 0 to 1. Now you can't actually put a 1 in there. That's why I did the limit, because you can't. If you get to 1, then it's going to be undefined. You have to go right before 1, and that's what that is. That's right before 1, and then we're going to add that. So here, just for like illustrative purposes, that's this area right here. This area right here. This was going to color it in. This part. And that's all the area right there. That's the red. Okay. The orange. So we're going to add this to the limit as A approaches 1 from the right. And we're going to do A to, wait, where are we going again? 3? Yeah, 3. Of bx. Okay, so we're adding those two together. Let me color in this. So those are 1, 2, 3. So this part right here is the orange part. Kind of sloppy, sorry. Okay. Okay. You have to break it down like that and add both of those together. Okay. So let's work this out. It's going to be some good practice with antiderivatives. A little bit of u substitution, it looks like, too. Now, since both of them have the same antiderivative, what I'm going to do is actually do the antiderivative separate and using a little bit of u sub. It's just kind of good practice for it. Now, I know you don't need u sub necessarily for this problem. So if you're one of those people that can look through that and go, oh, I don't need u sub, the inner derivative's linear. That's great. Like, do your thing, whatever you want. I don't care. But I'm just going to do a little bit of review for the u sub here. So I'm going to first just do the antiderivative, and then we're going to use this in the problem. Okay, so we're going to do this antiderivative right here. Let's get rid of this. Oops. Okay, so your u is going to be the most varied function, which is 1 minus x. So I'm going to put that as my u. Okay, I'm going to highlight it too, just for fun. So that's our u. Okay, you have to find the dx here. I should color code that a different color. Okay. So we're going to look for this dx here. We have to solve for that. Okay. Well, the only way to get the dx is to do the derivative of u, and then the dx pops up right on the bottom there. And this is equal to -1, because the derivative of the green is -1. You should know that from Calc 1. All right. From here, I'm going to multiply both sides by dx because I need dx. Okay. This is going to cancel. And then we have du is equal to -dx, okay? Or if you wanted to, you can say negative du is equal to positive dx. It doesn't really matter. I multiply both sides by -1. Okay, and then really quick, I'm actually going to save this because I feel like if I lose it, I'm going to be upset.
I have a question.
Yep.
Could we use things that like you haven't? Could we use things that you like haven't taught yet, like in exams? Like, could we use like power series on this problem?
Would it make it easier to do it that way? I mean, I shouldn't ask that. If it's easier for you, then yeah, sure, why not? We're literally going over power series in 2 weeks.
Okay.
So, yeah, whatever you want to do, man. I'm just wondering if it's faster that way. You bring up a good point, though. It's interesting.
I just figured because the base formula is like
Right.
1 over.
Ad shows up. I get what you're saying. That's cool. Yeah, whatever. I won't get mad. If I do mark it wrong on because I'm just being dumb or something like that, just let me know. And then I actually reward that too. If I rate someone incorrectly and they call me on it. And I do that on purpose because some people are so scared to tell me that I messed up that they oh, I just don't want to upset the professor. I'll give you more points if you prove that I'm wrong. Just as because I've never actually seen anyone do that before. So I could see myself going, what is this guy doing here? What is that? Unless you actually wrote, I did power series, but so yes, absolutely to answer your question. All right, so we're gonna substitute this in here, and you're gonna end up with 1 over u squared, and then your dx is equal to -du. So I'm gonna write times -du here. Okay, so we got the antiderivative going here. Now I'm actually going to cross this out and write u to the -2 just because it's an easier antiderivative. I'm also going to make this a plus and put the minus on the outside just because it's easier for me. I just prefer it that way. Okay, so then your answer is going to be, and we'll write it down here, is going to be -u, and you have to add 1 to the power, so you get -1, and then you divide by that new power, which is -1. So you add 1 to the power of this -2 here. So I got -1, then you divide by that power. Should be review. Plus c. Okay. The negatives cancel here. And I'm going to resubstitute in the u, which is the green right here. This 1 minus x. So it's just going to be 1 over 1 minus x plus c. Okay. So I'm going to use that antiderivative essentially to figure out these areas right here from 0 to b and a to 3. Bleh. Okay. So that's what I'm going to do. I'm going to use that blue right there. Let's blow this up a little bit. Okay, so this is going to be equal. Whoops. Hold on. So this is going to be equal to the limit as b goes to 1 from the left. And we're going to, oops, I don't need that anymore. Okay, because we already did the antiderivative, so we're going to, oh man, that's so sloppy. So we're doing the limit of 1 over 1 minus x, and we're integrating this from 0 to b, okay? Is there any questions so far on any of this? I feel like I made a huge jump there.
How come in this example you like what's the signal that you split it up into like the B limit and then the A limit?
All right, awesome question. So the main thing is the fact that you have to, and this is really important to know too, because on the quiz, it's not going to say, this is improper integral. Like you have to know that it's an improper integral. The fact that this right here, if you plugged in 1, so 0 to 3, there's a 1 in there. So between 0 and 3, there's a 1. If you plugged in 1 here, you would be dividing by 0. That tells you that it's an improper integral.
Oh, perfect.
Yeah,
Thank you.
I kind of went over that in the beginning too, but I went really fast. But here's the graph of it. If you notice, it goes from wait, oh man, I just realized I made a mistake. Why did no one call me on this? I don't want this. I'm going from 0. I don't want this area at all. That's embarrassing. Okay, but I'm going from 0 to 1 on the left side of the 1. And you can see, does that actually go to infinity? It kind of looks like it does, but sometimes it doesn't. As you saw from the last problem, we went to infinity and it still gave us a whole number, a constant number. But you can see it's 0 to 1 and you're going all the way up, and then you have to go from 1 to 3. And you just basically have to see what's going on at that x equals 1. So that's how you can tell. Okay, and definitely be on the lookout for that, because I promise that's going to be on the quiz and you have to kind of know it. And again, if you actually did the problem out, unless I made a mistake, I got -3/2. If you did it without taking into account that 1, okay, because if you just ignore the 1, if you do the antiderivative of what's in front of you there, you plug in 3 and you plug in 0, you get a value, and you shouldn't, because the answer for this is actually infinity, but we're not there yet. Spoiler alert on that, sorry. So we're doing that. We're going 0 to b here. Whoops, I'm on the eraser still. Okay, and then we're going to do plus the limit as a approaches 1 from the right this time. Going, oh man, I did it again. That's embarrassing. All right, we're doing 1 over 1 minus x, because that's the antiderivative. Let's put some brackets on this. And we're going from A to 3. Okay. So the only thing left to do is plug in B, plug in 0, plug in 3, plug in A, and subtract those out. And then whatever values you get from that ends up giving you the answer. Okay. So let's do that. So next step is I'm going to plug in the B, and then plug in the 0 and subtract them. Then I'm going to plug in the 3, plug in the A, and subtract them. Remember, that's the first fundamental theorem of calculus. That helps you find the area of each of those bits. Okay? I should say intervals. All right, so we're going to do, it's the limit as B approaches 1 from the left of 1 over 1 minus B minus, now you plug the 0 in there, you're going to get a 1. Okay, let me use a different color here. Plus limit as A approaches 1 from the right is going to be, oops, I did this in the opposite order. That's really bad. Hold on. Can we move this over? It doesn't really matter. I'm just being a stickler on this. If you plug 3 in there, you're going to get -1/2. Whoops. You get -1/2, and then you're going to subtract off. So I plugged the 3 in there. You don't need a limit for that. Doesn't matter if you did it or not, but it's -1/2 in there for that one. Minus when you plug in A in there, so it's going to be 1 over 1 minus A, this limit right here. Okay. Everyone's still on board here? You should be able to explain every little number, every little thing that I have. Like, why is that there? You should be able to answer that in your head. If not, then that's when you ask questions, because it's what I get paid for here. Okay, so now we're going to do a little bit of limits here. What is this value right here? This limit? Anybody have any ideas? If you plugged in 1 from the left, to that limit, what would you get? 1 over what? Okay, you would get, if you did direct substitution, you get 1 over 0. Okay, 1 over 0 means it's either going to be a positive infinity or a negative infinity. Okay, well, we already know from the graph it's positive infinity. You can see as you're approaching, the graph approaches from the left, going closer to 1 from the left, it's going to be infinity. Another thing you can do is just, it's 1 over a positive number. So it's 1 over 0, but it's 1 over a positive number because if I zoom in here, if you plugged in 1 from the left, it's like 0.99999 repeating. So 1 minus 0.9 repeating is positive. So we know it's 1 over 0. It's either positive or negative infinity. Since it's positive, it's going to be positive infinity. So I'm going to put an infinity underneath this. Minus 1. Hold on 1 second. Is that supposed to be negative? That is negative. I'm going to do negative 3 halves here. I'm going to combine the 1 and the negative 1 half there, because you can do that. Okay. This one right here, it's going to be minus. So this one right here, if you put this limit right here, the orange, if you plug in 1 on this one, you're going to get 1 over 0, which is positive or negative infinity, because it's one-sided. But the bottom in this one is actually going to be negative, because this one is 1.0 repeating with a 1 at the end. And you're doing 1 minus something that's slightly bigger than it. So it's approaching 0, but at least it's from the negative side. So it's going to be negative infinity because of that. So it's minus negative infinity. So zoom out here. Okay, well, minus a negative infinity is a plus infinity. This is meaningless because we're talking about 2 infinities here. So the answer for this one is actually going to be infinity. Or if you want, you can write divergent as well, because technically there is no solution for it. I would accept either or, but I know some professors would say, no, it's got to be divergent. It's not infinity. So it is what it is. Okay. Divergent just means it doesn't converge on a specific value, like the first one did, where it was 1 over 2 e to the 6th. That's converging on a value. All right, questions on any of this? I know it's a lot. None? All right. Fair enough. Let's do another one. So we're just going to go to the next one. Holy moly, look at this one. This one's crazy. Okay, number 3. Okay. All right, so we have a lot going on in this one. It's definitely a U sub problem because we have a buried function in there. You can't look at that and go, oh, there's a rule for that. There is no rule. You have to use integration by substitution. And then you'll see that you can use an integration rule after that. But until then, we do have to do integration by substitution on this problem. I'm going to try to do this one without the limits, just so you kind of get a feeling for what it looks like to work with infinity. So this is going to look a little different, but not a very small difference. All right, first thing I'm going to do here is I need to find the antiderivative, and then I'm going to plug in infinity and plug in 1. Okay, that's what, like, a light bulb should be going off in your head when you see that. That's what you need to do. So in order to do that, what I'm going to do is I have to find the antiderivative. I'm going to use U substitution, like I kind of already said. And your U is going to be the most buried function in there. So I'm going to say my U is equal to 1 plus x squared. Okay, always do that. Your U is always going to be that most buried function 99% of the time. Okay, always try that one first. Okay, so that's our U. Okay, we need the dx here. So what I'm going to do is take the derivative of U. So then the dx pops up, which is awesome. And then you end up with 2x here, which is pretty awesome. Because if you multiply both sides by dx, you're actually going to get du and then divide both sides by 2. Du over 2 is equal to x dx. Well, if you look up here, we need an x dx. Here's the x, here's the dx. So x dx is actually just du over 2. So now I can rewrite that entire thing right there as that x dx as du over 2. And that's actually what I'm going to do. So I'm going to rewrite everything based on the substitution. So we're going to go from, forget the 1 to infinity right now. I'm going to deal with that in a little bit. But it's going to be 1 over u squared. X dx is equal to du over 2. So I'm going to put that there like that. Okay. Now everything is in terms of u in this case, so you have to make everything in terms of u with the integral. Okay, the limits of integration. This goes from 1 to infinity. As are in x, it's in terms of x. It says of dx right here. Now we have u's. You have to transform that 1 in infinity to u's. So what you need to do is use that red equation that I have. Whoops. You have to use this red equation right here to transfer all those x's to u's. It's like a converter. Okay, so what we're going to do is we're going to put a 1 in there for the x, and it's 1 plus 1 squared is 2. So I'm going to put a 2 here. Okay, I'm going to put an infinity in there. 1 plus infinity squared is still just infinity, so I'm just going to put an infinity there. Okay, any questions so far on what I've done? If you notice, I did not do that in the last problem with the u's because, actually, I don't know why I didn't do it. You don't have to do it, I guess. It's kind of good to show you both ways of doing this. But I did not change the limits of integration. Oh, because you know what? Because I did the antiderivative here in one instance, and then I moved it up there. That's why I didn't do it. But either way, it doesn't matter. But if you notice, I shortcutted that. I still had 0 to b and a to 3. This one, I changed it to 2 to infinity because the 1 to infinity, it has to be in terms of u. And this is actually a good thing because it's one less step, but it's not like a huge step, so it doesn't really matter. Anyway, are there any questions so far? Please stop me if you do have questions. Pay a high enough tuition. You should be able to get your questions answered. All right, first thing I'm going to do here is I'm going to rewrite this. So I'm going to make this u to the negative 2, and I'm going to move this divided by 2 to be a 1/2 on the outside. I just like doing that. You don't have to do it that way. It doesn't really matter. Okay, it's completely up to you. I just think it looks prettier. Okay, so we're going to have 1/2. I'm going to do the antiderivative now of u to the negative 2, which is just going to be u to the negative 1. You add 1 to the power, you divide by that power. Okay. And then we're integrating this from 2 to infinity. Okay. Now we're going to plug infinity in first. But what you're going to get, actually, let's do this. Let's pull the negative out in front here too, just so it's a little bit easier. This can be gone. All right, so you're going to get negative 1/2, and then you're going to end up with u to the infinity to the negative 1 power. So that's just going to be 1 over infinity. Okay, then you're going to plug a 2 in, and it's going to be 1 over 2 because this u to the negative 1 is really just 1 over u. So I plugged in infinity, I plugged in 2. You should see where everything comes from. Okay, what is 1 over infinity? Anybody, just yell it out.
0.
0. Exactly. So this is 0 because if you have 1 pizza divided by infinitely many people, everyone gets nothing essentially. So you have 0 minus 1/2. Well, this is negative 1/2 times negative 1/2, and you end up with 1/4 is your answer. Which is weird because you're going to infinity, but you still end up with 1/4. Pretty interesting. Again, we're going to talk about that more when we do convergence testing. So you'll see that later on. Also, if you notice, there was no division by 0. If you look at the original expression, there's nothing that you could throw in there that would divide by 0. Okay. I mean, I guess an imaginary number, but there's no imaginary numbers in calculus, thankfully. And we're going from 1 to infinity. So there's nothing that can make that bottom 0 to where you're dividing by 0 like the other one that we did. So I do want to make sure you understand the difference between these. These ones have infinity as one of the limits of integration. This one has it where you're dividing by 0 from the limits of integration. They're both considered improper integrals though.